Okay, so the question here is, determine the density of the following liquid and determine if it is most likely to be water, which has a density of 1.00 gram per mil, ethanol, which has a density of 0.789 grams per milliliter, or 1-propanol, which has a density of 0.803 grams per milliliter. So you do an experiment in which you determine that the mass of a empty graduated cylinder is 4.32 grams. And with a certain volume of liquid, the new mass of that graduated cylinder is now 26.42 grams. Now, this will enable you to determine the mass of your liquid, but in order to know the density, you also need to know the volume. And so you have all of this liquid in your graduated cylinder, and you can see that it forms a meniscus, this liquid, a meniscus approximately around 27 milliliters or so. You know that it's somewhere between 25 and 30 milliliters, and most likely closer to 25 than to 30. And so you can say then that we have 27 milliliters. Now, I guess you want to be writing a number here in deciding what volume to write. You want to write a number which has one or more digits which you are confident of. And then it's important that the very rightmost digit, the smallest one, you are uncertain of. Now, this uncertainty generally should range between a 1 above and 1 below the number that you're writing. So, for example, we are going to write 27. We'll choose 7 because we're fairly confident that that digit is somewhere between 6 and 8. Now, what if you were to write 27.1 milliliters as your volume? Would that be reasonable? Well, yes, we are confident that we're within the 20s range. Are we confident that we are 7? Maybe, but are you confident that you have above and below the 0.1 here, that you have between 0.0 and 0.2? I'd argue you probably have no idea, being that this graduated cylinder is not particularly graduated. It's not defined as 26, 27, 28, or even more defined 26.1, 26.2, etc. And so, being that there's quite a bit of uncertainty here, we're going to be saying that we have 27 milliliters as our volume. And so now we have what will enable us to find mass while we're calculating density. So, density, we need mass and volume, and so we want to determine the mass of our liquid. Now, we know that the graduated cylinder with the liquid is 26.42 grams, and we know that the graduated cylinder itself is 4.32 grams. So we can determine that the mass of our liquid is 22.10 grams. Now, it's important, though, that any numbers that we're writing following calculations have the proper number of significant figures, or at least are as precise as they should be. And so you see that we are doing a subtraction here. And you may recall from honors chemistry or regular chemistry that when you do an addition or subtraction of a number, you should be reporting the result of that to the least significant, or actually kind of depending upon the decimal place. And so what I do when I do an addition or subtraction is I say, okay, I've lined all of these numbers up so that the decimals are all in the same place, and then I consider where do the significant figures end. And you'll see that the significant figures in both of these numbers, they end after having 2 places to the right of the decimal. And so we're going to be considering that any numbers beyond that we will not consider in our results of our calculation. And so we're only going to be writing that we have 22.10 grams. How many significant figures are in this number? Well, you would definitely say that the 2 here and the 2 here and the 1 here are significant, should you say that the 0 here is significant? Well, actually, yes. You want to consider zeros significant if there's a decimal place present. So if we have a decimal, such as here, then a 0 will most definitely be significant, whether it's to the left of the decimal or to the right of the decimal. And so we can consider all these to be significant. We have 4 sig figs in this number for our mass. And then we can also consider our density. You recall that we reported to have, well, just 2 sig figs in this 27 mils. And so in our density calculation, we're taking a number with 4 sig figs and dividing by a number with 2 sig figs. Now, when you do a multiplication or division, it's important that you are using just the least number of significant figures. And so multiplication or division, you want to use the least number of sig figs in your calculation. And so considering that, how many sig figs should we have in our result here? Not 4, but 2. And so we'll want to be keeping these numbers. So you might want to write 0.81 grams per milliliter. However, you see that we're crossing these numbers out, and being that this most recently crossed out number, this 8, is 5 or greater, we actually have to round this 1 up. And so in fact, instead of having 0.81, we're actually going to have 0.82 grams per milliliter. So we can determine that the density is 0.82 grams per milliliter. And so we've answered our density question. Now the question is, which of those liquids are we dealing with? Are we dealing with water, ethanol, or 1-propanol? Well, we have 0.82 grams per milliliter, so we're most likely dealing with the nearest density, 1-propanol, 0.803 grams per milliliter. Now, this is the most likely density. However, are you very confident of this liquid being 1-propanol? Well, you might know that we're quite uncertain still about this digit. In fact, instead of saying that we have 27 milliliters of volume, we might say that we have 28 because, again, we are uncertain of that last digit. And so if somehow that volume were 28 mils, then in fact the density would be 0.78 grams per mil, which should suggest that we are dealing with ethanol. And so it's hard to know whether we actually have ethanol or 1-propanol. We just have a bit of uncertainty about what we're dealing with, really because we are uncertain about our measurements. And that uncertainty in our measurement was properly followed in describing the uncertainty of our numbers. This is why we care about uncertainty in measurements and then uncertainty in reporting significant figures. We want to express to the reader of our research how confident we actually are about what it is that we're dealing with. Now, we can also do a little bit of a dimensional analysis problem here as well. Let's answer another question. How many liters would be occupied by 1 kilogram of this liquid? So we know that we have 1 kilogram of the liquid. How many liters are we dealing with? Well, you could do the traditional density is equal to mass over volume, and then rearrange to get volume is equal to mass over density. Now, it's important then that you would not only use your number of grams over grams per milliliter to determine milliliters and then liters, but also you convert your kilograms into grams. It's a lot. There's so many conversions of units here that it might be more effective to do just one large dimensional analysis problem. And so you might want to go from your kilograms to your grams, and then from grams to milliliter, knowing that you can go between grams and milliliters with our certain density. And so what you can do is go from kilograms to grams. You can say that 1 kilogram is identical to 10 to the 3 grams. There's 1,000 grams in a kilogram. This equality, this fact that 1 kilogram is the same as 10 to the 3 grams, allows us to build this unit conversion factor. And when we take our kilograms and then we divide it by kilograms, we're left just with grams here. And then you can convert your grams into milliliters. You can say that it was 0.82 grams per 1 milliliter. Grams is now out as a unit. And then milliliters can be crossed out as well because we know that 1,000 milliliters is the same as 1 liter. And so with a dimensional problem like this, you can sometimes save a lot of time. You can say that you have 1.2185 liters, however, you're probably going to have too many sig figs here. In fact, how many sig figs should you have? Should you be reporting just 1 sig fig, being that we started with 1 sig fig in our kilograms? No, actually, this is an exact number. And exact numbers do not affect the number of sig figs in our answer. Here we have 2 sig figs, so we should have 2 sig figs in our answer, and so we should say 1.2 liters.